last meeting, I started with you with this example. For this truss, we are looking to determine the internal forces in member AB, AE, ED. First step, you have to figure out your reactions. Second step, we are looking for member AB, this one, and AE, this one, and ED, that one. Let's start with any members intersect together. I believe member AB and AE intersect together at A. So I'm gonna talk about joint A. Joint A. Joint A looks like a point, particle, joint in equilibrium. What do you have at A? You have to draw your joint. Here is joint A. What do you have, or what are the forces intersect at point A, at joint A? What do you have here? We have XA, which is 6 kilonewton. We have YA, how much? 1 kilonewton. We have horizontal member will have a force called FAB. We have another member called FAE. All of these stuff intersect at point A, intersect at joint A. Do you have anything else intersect at joint A? Be careful. You have to include everything. Don't forget any. By the way, this angle equal 45 degrees. For any joint, for any particle, for any point in equilibrium, we have two equations. Summation f of x equals 0. Summation f of y equals 0. Let's start with the first equation. Summation f of x equals 0. What do you have in x direction? We have this force, we have this force, and we have two components. This component for FAE cosine 45 degree, and we have vertical component for this force FAE sine 45 degree. Until this moment, I have some students still confused which one is cosine, which one is sine. The adjacent component to your angle is cosine. Okay, go ahead and tell me which forces in x direction. We have positive FAB. We have positive FAE cosine 45 degree. We have negative 6. Make sure you included all components in x direction equals 0. Second equilibrium equation, summation f of y equals 0. What do you have in y direction? We have positive 1. We have positive FAE sine 45 degree. Anything else? No, equals 0. From the second equation, the only unknown here is FAE. So I can figure out what is the value of FAE. It will be 1. Make sure you will move this one to the other side. It will be negative. So this value will be negative 1 divide sine 45 degree. It will be negative 1.4 kilonewton. This value is negative 1.4 FAE. So put this value negative 1.4. So I can figure out from this equation the value of FAB. Make sure what is the sign. Your sign will be positive 7. So final decision, FAB equals 7 kilonewton, FAE equal negative 1.4 kilonewton. Do you remember, guys, last time I told you what is the meaning of positive value? What is the meaning of negative value? Do you remember? Positive value means assumption is correct. Negative value means your assumption is not correct. What do you mean? I mean, for if AB, you assumed it as a tension, pulling this point. So it's tension. Yeah, it's correct, tension. For FAE, I assumed it tension. But your value is negative. You assumed wrong direction. You should assume it compression. So I will not change any. Just I will say this value is 1.4 and it's compression. This value is 7 and the tension. That's it. Do you have any questions so far? I covered all of this stuff last time. We missed only this member, FED. By the way, AB is tension. So I'm gonna put the direction like this, tension, and it will be tension on the other side. Guys, this member is in tension, that's right? FEB in tension, 7 kilonewton. Tension means related to this joint is tension. Related to the other joint on the other side is tension also. Guys, AE, FAE is compression. So related to this joint is compression. Related to the other joint on the other side of the same member is compression. How much? 1.4 kilonewton. Now I'm looking for member ED, this member. So I'm gonna talk about joint E. Joint E. So what do you have about joint E? Please make sure you include everything at joint E. Everything intersect at joint E. What do you have? We have this force. Looks like this. How much? 1.4. We have this one. 1.4. What else? We have vertical member EB. FEB. What else? We have horizontal member ED. FED. I'm talking about all stuff intersect at joint E. We have member, we have member, we have member. This member, how much? 1.4. This member is unknown, this member is unknown. Do you have anything else at joint E? No, nothing. Nothing intersect at joint E, nothing. This 6 at D, this 8 at B, nothing at E except 1, 2, 3. Guys, from the first step, I figured out that the force in this member is 1.4 compression. Compression means related to this joint is compression. Related to the other joint on the other side of the member is compression also. So we have a force here, 1.4. So go ahead and apply summation f of x equals 0. We are looking for this one only, FED. So Remember this member with angle here 45 degree. This member is 45 degree here. It will be 45 degree here also. Anyway, so we have horizontal component. It will be 1.4 cosine 45 degree. We have vertical component 1.4 sine 45 degree. Anyway, we are looking for summation f of x. We have positive FED. We have positive 1.4 cosine 45 degree. Do you have anything else in x direction? This one and this one only equals 0. That means FED will be negative value. How much? 1.4 times cosine 45 degree. Your value equal 1 kilonewton. I'm looking for FED only. ED only. So I will not complete summation f of y equals 0 because I don't need anything else. That's enough. I'm looking for FED and I am done. My question is, anybody can tell me what is the meaning of negative? Assumption is not correct. Okay, what did you assume for FED? I assumed it pulling this joint E out. So it's the tension. No, it's wrong. It should be compression. So I'm looking as an instructor from you as a student to tell me what is the value and what is the final decision. Is it tension or compression? Any question, guys? Do you have any question? One more example. One more example. We have a truss with roller support at B and the hinge support at D. We are looking for forces in members AB, AF, BF. Do you remember what was the first step? Reactions. First step is reactions. This one is a roller, so we have only one reaction, YB. This one is a hinge, so we have two reactions, YD and XD. One of you will ask me, hey, this hinge looks like inclined hinge, like this. I don't care. I don't care about the hinge. If you have hinge, or sometimes we call it pin, we have two reactions, one vertical and one horizontal. I don't care if this hinge is inclined or not inclined. We have only two reactions, one vertical and one horizontal. I can make concern only if you have roller. If you have roller, inclined roller, yeah, I can pay attention because your reaction is only one and this reaction must be perpendicular to this base. But this is only for roller. If you have hinge or pin, I don't care about the inclination of the support. We still have one vertical and one horizontal component, so I don't care. By the way, your reaction, I will not waste more time. Your reaction, I can tell you 4 times 12 plus 4 times 24 plus 2 times 36 divide 24. This reaction YB will be 9. Skip. If you apply summation f of y equals 0, this reaction will be 1 kip. If you apply summation f of x equals 0, this reaction will be 0. So reactions y b will be 9 kip, y d will be 1 kip, and x d will be 0 kip. If you apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. I recommend it to take moment at d. You will find these reactions. Let's start. I'm looking for AB and AF and BF. Which two forces are intersect at one joint? I believe AB and AF. Both of them intersects where? Both of them intersects where? Any answer? Okay, wait a moment. Thank you, A joint. Thank you, Jos. Mitchell, why did you keep 1.4 cosine 45 degree? Are you talking about this one? So please, can you watch this direction? I don't care about the sign, guys. Guys, the sign for FEE AE is negative. This sign to tell me a message. Once you received the message, please forget this sign anymore. What is the message beside this sign? The message is your assumption is not correct. I assumed the FEE as a tension. No, this assumption is not correct. This force must be compression. Did you receive the message? Yes, I did. Forget the sign. So this force is a compression to this joint. And the value is 1.4. Okay? If you are trying to get the horizontal and the vertical component, this force as a horizontal component will be like this, which is in positive direction of x. You got it? We have a sequence. Guys, we have a sequence. We have a sequence. Once you received the message from the sign and put the right direction of FABAE, the right direction is compression. So I will never need this sign anymore. So Mitchell, did I answer your question? Okay. Juice, thank you. Yes. Member AF and the member AB are intersecting at joint A. So I'm gonna start with joint A. So guys, in any truss problem, you have to start first with reaction. Second step, you have to look to a joint. The required members are intersecting at this joint. One will say, hey, we have another member BF. Okay, wait a little bit. We will start with AB and AF, which are intersecting at A first. Okay, here is joint A. Please go ahead and tell me everything intersect at joint A. Everything, don't forget any. So we have vertical force, how much? 2 kip. We have horizontal member, I'm gonna assume it like this, tension, FAB. I have inclined member like this, FAF. The most important question, do you have anything else at this joint? Do you have anything else intersect at this joint? No, we don't have. So if you assume this angle theta, which equal to this angle theta in this right angle triangle, so I have right angle triangle like this, and here is the angle theta. This distance is 12. This distance is 9. I can figure out the third distance will be 15. So sine theta will be 9 divide 15. Cosine theta will be 12 divide 15. Anyway, go ahead and apply summation f of x equals 0. For x, we have horizontal component here from this force, FAF cosine theta. We have vertical component here will be FAF sine theta. So what do you have in x direction? We have positive FAB. We have positive FAF cosine theta. Nothing else. This one and this one equals 0. Make sure FAB, make sure cosine theta equal 12 divide 15 FAF. I cannot do anything more. Summation f of y equals 0. What do you have in y direction? We have positive this component, FAF sine theta. We have negative this force. How much? -2. Nothing else. Nothing else in y direction at this joint. Don't forget sine theta as a value equal 9 divide 15. The only unknown in this equation will be FAF. This value will be positive, by the way. If you move -2 to the other side, will be positive. It will be 3.33 kip. Please go back to this value and put FAF equal 3.33. So I can figure out the value of FAB. FAB will be negative, I believe. If you move this value to the other side, it will be negative. 2.67. I would like to adjust my calculations and my directions I assumed before continue. So please adjust yourself. FAF is positive. What does it mean? FAF is positive means your assumption is correct. I assumed the correct direction, which is tension. So this assumption is correct tension. It will be correct on the other side tension. Guys, this arrow related to joint A. The other arrow related to joint F. Your arrows must indicate tension on both sides of the same member. How much? 3.33 kip. Guys, FAB is negative. What does it mean? You assumed the wrong direction. I assumed it tension. No, it's wrong. It should be compression. Okay. So your correct direction here will be compression related to this joint and the compression related to the other joint on the other side. So the two arrows indicate compression, but this one indicate compression to joint A, the other one indicate compression to joint B. How much? 2.67. Please forget the sign. The message behind this sign is done. I received it, which is tension or compression. Once you receive the message, please forget it. Your value right now, 2.67. Your value right now, here, 3.33. Any questions so far? I am done with AB. I am done with AF. I'm waiting for any question. Thank you. Yeah. This point is confused. I know. If you have a member, we have only one member. This one is one member. Connect here at joint and connect here at another joint. For example, based on your calculations, we decided that AB is tension. Based on your calculations, we decided AB is tension. You are talking about AB. It's only one member. So one member remain under tension forever. So this member is tension related to this joint. This member in tension related to this joint. Because you are talking about the same member. So your member is in tension. So tension related to this joint looks like this. Tension related to the other joint looks like this. If your member, this point is confused, I know. So I need to make it clear. If you have a member, and based on your calculation, we decided member AB is in compression. You decided this? Yes. So this member is in compression related to this joint will be like this. Pushing this joint. Trying to push this joint. The same member related to the other joint will be compression. Trying to push this joint. You got it? You got it? So you are drawing arrows trying to indicate what is this member try to do to this joint and this joint. In this direction, this member trying to push this joint and to push this joint, pushing mean compression. This member trying to pull this joint and pull this joint, so this member is in tension. Okay, this point is very important. Okay, guys, we are done with AB and AF. We're still looking for BF. Where is BF? Here you go. This one. We have two options. Either I need your recommendation. Do you think I'm gonna use joint F or I'm gonna use joint B? What do you think? Because member BF connecting between joint F, so I can do joint F. Or joint B, I can do joint B. So what do you think? I think joint B will be more easy. How many members do you have? 1, 2, 3, and one reaction. But here we have 1, 2, 3, 4, and 1/4. So it's crowded. Joint F crowded. I'm gonna use joint B to be more easy. So for joint B, please put joint B here and try to list everything intersect at joint B. Everything. The first one, we have vertical reaction here. How much? 9. Okay. What else? We have a member from this side. How much? You know it? Yes, I know. 2.67. Positive or negative? I don't care. We have this direction, 2.67. My concern is direction and what is the value. We have vertical member here, BF. Are you done? No, wait. We have another member here, BC. Guys, we are looking only for this force. Make sure you remember it. At point B or joint B, we have only 1, 2, 3, 4 things intersect at point B. After you are done, after you draw your joint and everything intersect at this joint, go ahead and apply summation f of x equals 0. So we have positive 2.67, positive FBC equals 0. It's very easy. We don't have any inclined forces. So FBC equal negative 2.67. Actually, I don't care about FBC because I'm not looking for this one. Summation f of y equals 0. We have positive 9. We have positive FBF equals 0. The only unknown in this equation is FBF will be negative 9. Kept. Guys, what is the message behind the negative? What is the message behind the negative? You assumed the wrong direction. I assumed it like tension. No, it's wrong. This force must be compression. If you would like to go back, this one is 9 compression. If you would like to go back to this member and trying to put the correct direction, it will be compression here, like this, and the compression here, like this. How much? 9. So guys, my final decision, my final conclusion for this problem, AB equal 2.67 compression, AF 3.33 tension, BF equal 9 compression. I am done with this problem. Any question? Any question? So until this moment, we covered 2 parts in this topic for trusses. The first one, how to identify zero force members. You can look to the truss and say, hey, this member is 0. The force in this member is 0. We have 2 cases. Do you remember them? Case number 2 and case number 1. We can expect problem like this in your exam. And also the quiz on Monday will be in this part. The second one, how to use method of joint. Method of joint looks like what we learned in the second week in this course. We have a joint, we have forces from each direction. I don't care. These forces intersect at this joint, so I can apply summation f of x equals 0, summation f of y equals 0, so I can figure out the unknown. If your value is positive, you assumed the correct direction. If your value is negative, you assumed the wrong direction. What should I do? Nothing. Don't do anything. Just tell me the final decision for this member is tension. The final decision for this member is compression. Okay? We have another method. We have another method, which called section method. For section method, we have only 3 equilibrium equations: summation f of x, summation f of y, summation moment. What you mean by section method? Guys, I can, if you are looking for force in this member and this member and this member, 3 members, all of them are very close to each other. I can apply this method to get these forces in one step only. One step. But this method will be good for 3 members only. And these 3 members can be intersect or can be cut, I'm sorry, can be cut with one section. I'm sorry, what you mean by one section? I mean like this. I can cut this truss to 2 parts using this section. Your section passing through this member and this member and this member, so I can use this method. What will happen if you are looking for this member and this member and this member? I cannot use the section method. Why? Because I don't have section to cut these 3 members only. Can you? If you are trying to cut this one and trying to cut this one, you intersect this member. Doesn't make sense. Will not work. Your section must intersect the 3 members only. Can you? Guys, can you intersect this member and this member and this member only with one section? No way. If you are trying to cut like this, no way. You have to cut another member, this one. So that doesn't make any sense. So guys, we have some condition to use this method. Section method, you will cut only the 3 members you are looking for with one intersection, with one section. With one section. If you decide to use this side, your free body diagram looks like this. I didn't cut anything for these members, so I'm gonna draw them as they are. We have vertical force here. I will put it here. I cut this member, so I have a force. I cut in this member, so I have a force. I cut in this member, so I have a force. So we have 3 forces. We have 3 equilibrium equations, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. I can figure them out. Or you have another option to make your cut and use the right part. It's up to you. Both of them works. If you decide to use the right part, so we have these members without cut. Please put them as they are. We have reaction here. We have reaction here. Put your reactions. I did cut in this member and this member, so I have force here. I have force here. I did cut in this member, so I have force here. Go ahead and apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. I can figure them out. Make sure, and you have to trust me, if you used this side and they figured out these forces, another student used this side and figured out these forces, this one will be the same like this one, this one will be the same like this one, this one will be the same like this one, the same value and the same decision, tension or compression. Let me do this example. Let's try with this one first. Example number 7. We have a truss. Reactions are given. Wow. Probably sometimes this happens. 3 kb, 3 kb, 0. Reaction is given. We are looking for member GF, GD, CD. And we are looking to use method of section. Don't worry, I will tell you in the problem which method I'm gonna use. Do you think I can do cut? Do you think I can do one section to cut these members only? I think yes. Like this. Your section, cut these members only. Guys, by the way, if your reactions are not given, you have to figure them out first. So first step, your reactions. Make sure you have reactions. Second step, do the section. Third step, which side I'm gonna use? It's up to you. What you mean by which side? Yeah, guys, I cut this truss to two parts. This part or this part. So which side, which part you are going to use? It's up to you. You can use what you want, but I recommend to use the smallest part. Smallest part will be more easy. So I'm gonna use the right part. Right part, I didn't cut here. I didn't cut here. I didn't cut here. So these parts will be remain the same, like this. We have vertical reaction here, 3 kip. I have vertical force here, 2 kip. Please don't forget any. We have vertical force, we have reaction, we have these members without cut. And I did cut in this member. I did cut in this member. And I did cut in this member. This member FDC. This member is FDG. This member is FG. This member, and this member. Do you agree? It's very easy. This one is more easy. Please, what are your reactions? They are given. That's fine. That's great. Second step, do your section. Third step, you have to decide which part I'm gonna use. I decided here to use the right part. So what do you have in your right? We have members without cut. Keep them as they are. We have vertical reaction. We have vertical force. Your members, this member, I cut it. This member, I cut it. This member, I cut it. If you cut a member, you have a force. Last step, we have 3 equilibrium equation. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. Let's start. Summation f of x equals 0. For this part only. 5, so this angle is 45 degrees. Why? The horizontal distance is 5. The vertical distance is 5. So your inclined angle will be 45 degrees. Anyway, so summation f of x equals 0, we have negative FFG. We have negative FDG cosine. We have negative FDC equals 0. 3 unknowns. I cannot do anything. Summation f of y equals 0. What do you have in y? We have positive 3. We have negative 2. We have positive FDG sine 45 degrees equals 0. Guys, you should be, you have right now more experience. So this force has 2 components. One horizontal, FDG cosine, and one vertical, FDG sine. So apply summation f of y, we have 3, 2, and this component. The only unknown in this equation is FDG, so I can figure it out. Then summation moment. Guys, which point I'm gonna use to take moment? This joint is D, this joint is E, this joint is F. So what do you think? I'm gonna use joint D equals 0. Why? Because if you take moment at this joint D, this force will be cancelled, this force will be cancelled. So we have Fg times 5. This one will be cancelled also. We have 3 times 5 equals 0. So I can figure out Fg. So Fdg is known. Fg is known. So I can go back here to figure out the value of Fdc. So I am done. I can figure out GF, GD, and CD. This method called section method. For this example, we are looking for the force in this member and this member and this member. So I'm gonna use section method to cut these 3 members. So first step, you have to figure out your reactions. We have here 1 reaction, we have here 2 reactions. Second step, do a section to cut these 3 members. Third step, I'm gonna use the right part. Most easy. So for this right part, we have something looks like this. Vertical reaction here, vertical force here, 2 kilonewton. I did cut in this member, I did cut in this member, I did cut in this member. I did cut here, and the cut here, and the cut here. So I have 3 forces. 1, 2, 3. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point, I recommend to take moment here at joint C. Why? Taking the moment at C will cancel this force and cancel this force. So you still have this one as one unknown, so I can figure it out.